Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So let's say your friend tells you that they found a treasure right by your house. It's 50 kilometers away. What does that mean? 50 kilometers is kind of vague because it doesn't tell you where. It could be this way, or this way. Which way is it? Distance we call a scalar quantity. It's called this because it only shows you magnitude, it doesn't show you direction. If we say 50 kilometers to the northeast, now we know where it's located, how far away it's located, so we call this a vector quantity. Scalar quantities are only going to show you one dimension, the magnitude. Vector quantities show both magnitude and direction, so two dimensions. Speed is a scalar quantity that we know really well, especially those of us who have done driver's ed. Scalar means no direction, only magnitude. You're going 25 miles per hour. There's no direction in that statement. However, velocity, one of our new measurements we're going to use in physics, is going to tell you the direction as well. You're going 25 miles per hour to the right. That has both the magnitude, how much, and the direction.
Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Magnitude! With both direction and magnitude.
Okay, to summarize this, scalar quantity has only magnitude, but it doesn't have direction. Vector quantity is going to have both magnitude and direction. Every scalar quantity will only be one-dimensional, magnitude only. Vector quantity can be one-dimensional, two-dimensional, or even three-dimensional. Any change in a scalar quantity is going to be reflected only in the change of magnitude. Now, since vectors are both direction and magnitude, when a vector quantity changes, it can be changing its direction, or it can be changing its magnitude, or it could be a change in both the direction and the magnitude of the vector. Number 4 on this list, scalar quantities cannot be resolved as it's always going to have the same value no matter what direction it's going in. What that means is the vector quantity, if I said you were traveling 50 kilometers northeast, you would want to know how much of that 50 kilometers was to the north and how much of that 50 kilometers was to the east. So that's what it means by resolving it. It's like you're resolving a right triangle. You're finding the components of the triangle to the north and to the east. Scalar quantities can't be resolved because it doesn't matter what direction they're going in. You're only talking about the magnitude. Number 5 on this list is basically talking about the math between scalar and vector quantities. If you are going to do math between two scalar quantities, two or more scalar quantities, you're going to only get a scalar answer. You cannot get a vector quantity from without having a vector quantity in the equation. Number 5 on the vector side is a little confusing until we actually do some of the work. You can do math with vector quantities, and sometimes you're going to get a vector answer, and sometimes you're going to get a scalar answer. We have examples of vectors and scalars, scalar ones that you've used quite a bit already before you entered physics: length, mass, area, volume, speed. Chemistry, you were using pressure and temperature and energy. You probably talked about entropy in chemistry. Work, the physics definition of work is going to be different than the one you know. And power, those are all going to be scalar. Vector quantities we're going to use throughout the year will be displacement, velocity, acceleration, momentum, force, and weight. I did skip 3 of these because they're not actually in our curriculum, but for those of you who are into airplanes, lift, drag, and thrust, those are all going to be vector quantities because it's going to tell you the direction that motion is going to go in. So I hope you understand scalar versus vector after this short presentation. Scalar, quantity only, and vector is going to be direction and quantity. You heard it from Vector from Despicable Me several times, but I'll let you hear it one more time.